Hello students, let's see a different method to calculate the electric field on the equatorial line of a dipole. So we have the dipole here, namely AB with charges minus Q and plus Q. PO here is the equatorial line and P is the point of observation. Now recall E plus and T minus to be the individual vectors acting at the point P due to plus Q and minus Q respectively. Now let's mark the angles here to be theta either ways, and also let's see the directions of E plus and E minus. E plus, as it's due to minus Q, will take a direction from P to A, and E plus direction can be marked over here, say away from plus Q towards P. So that is like this way, which can be this way too. So mark the direction for E plus to be that way. So this way down we have direction for E minus mentioned there to be E minus. Now we are doing a method of resolution over E plus and E minus so that E net can be calculated. And first let's see a resolution to E minus, for which we need to imagine such two mutually perpendicular axes between which E minus, say the vector to be resolved is seen. So plan such lines or axes. So we have this way minus x-axis, this way minus y-axis. We chose them such a way E minus the vector to be resolved is seen between them. And now the angle, this one, that's a theta, which makes us knowing even this angle to be theta as per the property of alternate angles. So this angle you mark that to be theta. So with this axis, E minus is making theta as an angle. So for the same axis, the component of E minus can be E minus cos theta. And for the other axis, the component might be E minus sin theta. That is according to the concept of vector rules. And now for E plus, let's see a resolution. So imagine such kind mutually perpendicular axis such that between them E plus is fed. So axis, let us see. One axis to be coming this way, and the other axis is this way itself. Between them we have the vector E minus which to be resolved. Now angle concerns we have to see. As this is theta, the same kind of lines only here also. So we can mark here also an angle to be theta. So this angle is theta, say made by E plus over this particular axis. If you name this particular axis to be PP dash, so angle made by E plus on PP dash, that's a theta here. Now let's see the resolved components of E plus. So for this same axis, the component may be E plus cos theta. For the other axis, say y axis, the component can be E plus sin theta. Now these components can be combined together to decide for the E net. And when you look at the vertical components first, we have E plus sin theta and E minus sin theta directed in opposite directions. And more, when you have E plus and E minus here equal, both these components may be appear equal. So the components e plus sine theta and e minus sine theta, they are seen equal and opposite, so they will get cancelled. So there is nothing non-zero net coming in the vertical directions. And when you speak about the horizontal directions, we have two components, say e minus cos theta and e plus cos theta. Both are collinear, correctly equal vectors. So between them a net will be found as a sum of both. So we do like e plus cos theta plus e minus cos theta, which can result a net between them, which is for the overall electric field at the point say P as well. So E net, that is calculated as E plus cos theta plus E minus cos theta, and that can be reduced to be 2 E plus cos theta, either that or 2e minus cos theta, both of similar values, because e plus e minus we know them to be equal. And now once you substitute for e plus and cos theta, the final equation can be ready. And if you want the direction concerns, this is only a magnitude part. To make this particular quantity of vector, we need to introduce the direction. And if you look at the direction, each vector herein is pointing towards left, that is in the minus I cap direction. So for the net even, what the direction can be the same. So you introduce minus I cap here, which is for the vector E net. So this is how we calculate for E net's magnitude and direction through the method of resolution of vectors. Thank you.